Welcome again. I'm Sam Alcaine, an associate professor here in the Department of Food Science, to our food safety office hours. We're about 3 months into this H5N1 outbreak in cows. We're still at about 9 states. Well, not about. We're still at 9 states, right, with confirmed herds that are positive for H5N1. And I don't know about for the other panelists on the call, but it feels like the flurry of media calls has slowed down, but things are definitely not over. Looking at the USDA site today, there are a total of 82 positive herds. And in the last week, we saw a number of positive herds pop up in Idaho, a couple in Michigan, South Dakota, and Texas is still seeing positive. So, right, that's where we saw the first case on a farm in Texas a few months ago, and they're still seeing cases. So this is definitely not gone. Last week, we also saw the first human case of H5N1 with respiratory symptoms. So there's a lot of interest going on trying to understand what is going on there. And we've also seen a few now studies starting to come out on different inactivation studies and things like that that we'll touch on in the updates. And then we'll get to your questions. So we pulled together a great panel today. We've got Dr. Elisha Frye, who is an assistant professor of practice veterinary in the veterinary support services at the Animal Health Diagnostic Center here at Cornell. We've got Dr. Diego Diel, who is an associate professor in the Department of Population Medicine and Diagnostic Sciences and the director of the virology laboratory at the Animal Health Diagnostic Center. We've got Dr. Nicole Martin, assistant research professor and the associate director of the Milk Quality Improvement Program here in the Department of Food Science, and then Dr. Elisha Frye, who is a senior extension associate here in the Department of Food Science, all to kind of answer some of your questions. And we're going to start it all off with Elisha, who's going to give us an update on what's going on the animal side. And then I'll come back on, talk a little bit about what we've been seeing in foods, and then we'll open it up to everybody's questions. So with that, I'll pass it over to Elisha.
Hi, everybody. I spoke last time, so I'm just going to kind of give a brief update. This is the numbers of testing that we've performed on milk from dairy cows at the Cornell Diagnostic Lab since April 25th or 27th of this year. So we have tested 1,733 milk samples, and they're mostly from New York. So we did have 1,000 cow dispersal, and that farm elected to test every single cow, which was fine. The federal order states you have to test 30 animals, and if the shipment's over 30, you don't have to test more, but they wanted to test everyone. So that is a big chunk of the total testing we have done so far. We've also tested from New England states, Maine, New Hampshire, Massachusetts, Vermont, Connecticut, and then also New Jersey. We've had just a single sample from Texas, a single from Ohio, and then a couple from Pennsylvania and Maryland. So this is obviously just what our lab's doing. There are over 40 labs that can do this testing, but I just wanted to give you a snapshot of where we're at. And so 1,692 of them were for movement or screening purposes, and then 41 of the samples were animals that were sick or the vet was suspicious of H5N1. So the majority of the samples are clearly for movement purposes. We had some, I never likes to advance. We were given a list of questions from the audience, and so the ones that I thought I could answer, I just put together in a slide format for you all. So one of the questions was interested in hearing about infectivity of H5N1 from raw milk, and there was recently a paper that was just out in the New England Journal of Medicine, and the title is here, Cow's Milk Containing Avian Influenza, H5N1 Virus Heat Inactivation and Infectivity in Mice. And I think Dr. Alcaine is going to talk about the study as well, but I just wanted to note that basically they gave raw milk to lab mice, and the mice got sick, and then they euthanized the mice, and they checked different body parts to see how much virus, H5N1 virus, was in the different organs. And so the higher the bar is on the graph, the more virus was in the sample. So you can see the most strong positive is the lung, followed by the trachea, and then the nasal turbinates, which would be the nose. Interestingly, there was virus in the mammary gland of the mice, even though the mice were not lactating. And then the other parts of the animals were less concentrated with virus. Other questions that I thought I could answer, where and to what extent is the virus present in the bovine carcass? So the USDA Food Inspection Services tested 109 carcasses at slaughter plants, and they looked at the muscle specifically. One of the 109 was positive for H5N1 in the diaphragm muscle. And so this is a link here to that note on the USDA website. Yeah, another question, what is the cost of a milk sample to detect HPAI genetic material in milk? Seems like we should be sampling every farm regularly. All testing is paid for by the USDA. So they are refunding us when we run the test. So the test itself is at no charge to the farmer. You do have to pay to ship the sample here, but then the testing is done for free. Have there been any efforts to develop an alternative test rather than just the milk test? There's currently an antibody test underway for cow blood and cow milk, so that should be validated soon, probably within the next couple months. Has HPAI been detected in dairy herds outside the US? Not to my knowledge. Canada does require that cows coming from the US be tested, but that's kind of all I'm aware of. I don't know if anybody else wants to chime in on anything they're aware of for other countries. Has there been transmission from cows to other mammals on the farm? Yes. So we know that farm cats were fed raw milk, and we know that the cats got HPAI from that raw milk. A raccoon also got H5N1, and we know it was a strain that came from cows. So it has been transmitted to other mammals. What types of exposures seem to be highest risk at this point? What measures seem most protective? I wanted to reiterate there were 3 human cases. The first 2 just had pink eye signs, so reddened eyes. One was a Texas dairy worker and one was a Michigan dairy worker. And then more recently, as Sam mentioned, the 3rd human case, which was also in Michigan, had a cough and a fever. So signs that were not limited to pink eye. And that is all I had.
Oh, sorry. I thought I had myself unmuted, but apparently I didn't. So everyone hear me right now? I'm not just talking to myself like I normally do. Okay, great. So I'll thanks Elisha. I'll pick it up here from the food side and kind of talk a little bit about some of the updates that we've seen. So there was a lot of talk the past month about the study that FDA did where they sampled milk from the retail shelf. And some of that information has now come up. And Al, I think I sent you the links to post in there if you can in an email. But they published now a paper. It hasn't been peer reviewed yet, but it's out there on archive. And it gives you a little bit more information. So they sampled 297 samples. It was across, I think, 17 or 18 states, but it really represented processors from 38 states. If you go through that report, you'll see that there's actually about 15 states that have processors that had dairy products from their processing plants that tested positive via PCR for H5N1. Now, we don't know where these processors are sourcing their milk, so their milk may have been coming from those 9 states that have confirmed herds. Maybe they're not. We don't know that information, but there were definitely then some states that we hadn't seen before when talking about H5N1. Interestingly, we didn't see anything here from Idaho. It was tested, but nothing came back positive, though we know Idaho has some confirmed herds with H5N1. And then New Mexico and I think South Dakota are the other 2 that have positive herds, but didn't show up on the list, but there were no products tested from those states. Now, again, they mentioned 1 in 5 of the 297 samples tested positive via PCR. They followed up with infectivity testing using the eggs, and none of those showed any infectious virus. So again, kind of verifying that, pasteurization is eliminating the virus, inactivating the virus, and we're not seeing anything in retail products. So again, we're kind of just building our confidence that pasteurization is doing the job that we expected to do, that it's been doing right for us for the past 100 years. I thought some interesting things also to note in the studies that they talk about, which were the types of products that they tested. So they tested whole milk, 2%, reduced, 1% milk, skim milk, half and half, yogurt, cream, cottage cheese, and sour cream. And all those categories had at least one positive, except for yogurt. There was the yogurt, they only tested 14, but they didn't find any PCR positives in the yogurt. Maybe that's due to the higher heat treatment. Maybe that's due to the lower pH. Maybe, who knows? Or maybe it's just milk sourcing. But the others did have some positives. And then based on the CT values of the PCR, they made a standard curve and they estimated what the titers were in those products, which I thought was interesting, kind of giving you an idea of what's out there. And overall, the mean titer was 3, right? So 10 times 3 PFU. I think they saw the highest was 5.4. So kind of giving you an idea of what is going on out there. From what we've seen from, milk from sick cows, the titer is around 10 to the 7, right? So you see, right, that there's quite a bit of a dilution factor going on here. So there isn't a lot, right, potentially, going into the supply here. So it'll be interesting to see what other type of trace back might happen here, or what else we'll see. The other thing to remember, that this is only a snapshot, right? This was taken from April 18th to 22. So also, right, really what is going on in the landscape now is probably very different than it was then, and hard to make any assumptions about what that looks like. But definitely some interesting information. But again, kind of showing that pasteurization is doing what we expect. There was also the beef study out of USDA. Elisha alluded to, right? They did some testing on culled dairy cows, and all but one of those samples tested negative via PCR for H5N1. And they're doing a little bit of trace back on the one that did test positive. USDA also did a survey of commercial ground beef, so just like what FDA did for retail milk, and all of their samples were negative via PCR. And then USDA took it a step further, and they did a cooking study where they took 300-gram patties, which are a bit bigger than what we normally talk about for a size for patties, usually around 110 grams. And they cooked these patties to 120 degrees Fahrenheit, 145, and 160 degrees Fahrenheit. They had inoculated the meat with an H5N1 surrogate, so not actually H5N1, but a surrogate. And they found in what they've released, they said they found no virus at 145 and 160. So medium well and well done. And they said that it was substantially reduced at 120 degrees Fahrenheit, which is rare, right? And I mean, it's never recommended to eat a rare hamburger as it is, but there's that. So again, showing that, temperatures 145 degrees Fahrenheit, 160 degrees Fahrenheit are very effective at inactivating this virus, and that it is pretty susceptible to heat treatments. And kind of going on, just to remind everybody, what's going on the dairy side for overall control in milk. Just a reminder, the pasteurized milk ordinance, right? Really, we've got 2 mechanisms of control. The first one is we are supposed to only be sourcing milk from healthy cows, right, to reduce any potential load. And so again, right, the milk that we're seeing from clinically sick cows, right, is abnormal milk and shouldn't be sent then for processing. And then the other piece is pasteurization, right? So we have the continuous flow, high temperature, short time, 72 degrees Celsius for 15 seconds, and VAT pasteurization, 63 degrees C for 30 minutes. And there's some adjustments there for if there's higher solids, we knock up those temperatures by a little bit. There are verification studies being done at a couple institutions across the U.S. We've begun to see, so some of you may have seen I think it was last week that an article, or actually the week before, an article came out in the New England Journal of Medicine from a team at Wisconsin that looked at some viral samples that they had that were sourced from a farm in New Mexico and a farm in Kansas. And all this work was done in a thermocycler, right? Not in a commercial pasteurizer. And you could see that their incoming titers were ranging between 5 to 7, right, log. And depending on the heat treatment here at 6, interestingly, right, depending on the heat treatment and the type of method they used for detection, they used either cell culture, canine cell culture. This MDCK is the canine cell culture, and then they did the egg test. Via cell culture here, 63C at 5, 10, 20, and 30 minutes. It was below the limit of detection for their culture. Interestingly, when they raised the temperature and they did 5, well, this is 5, 10, 20, 30 minutes, did shorter times, right? A little less than pasteurization here. 15 seconds at 72C is pasteurization. Via the cell culture, they didn't detect anything there. But when they looked at it with their egg assay, there were not all of their samples, but they randomly got a couple hits where they did detect infectious virus still in the sample. But we got to remember that these are atypical milk samples, right? This mastitic milk, again, milk that we wouldn't be sending for processing. And so also its consistency might impact the way heat treatment works on it versus regular fluid milk. And then the other piece to remember is that this is done in a thermocycler and not done in, right, a continuous flow HTST. So the actual temperature treatments might not be what the milk is seeing. So these are some interesting results to keep an eye on, but we'll wait to see what comes out with the pasteurizer work. But here they were at least seeing a 4.5 log reduction in the virus based on their reports. When we go overall to raw milk, this is a slide that I shared in the very beginning, so like 2 months ago. And really, we haven't answered yet any of these questions. So just kind of putting it out there, we still don't know what the infectious dose of H5N1 is for this particular strain. We don't know how well the virus survives in raw milk cheeses over time. There will be studies, taken on shortly that are going to look to answer these questions. We don't know what sub-pasteurization treatments are sufficient to reduce the virus load. Again, that thermocycler study is very preliminary, but it does, right, it makes you keep in mind that, we're probably going to want things that are closer to pasteurization than lower. There's still a lot of questions around, what should raw milk cheese producers do? As far as testing their raw milk, if they're going to be making raw milk cheeses, and what to do if a herd tests positive. They definitely shouldn't be making cheeses with milk that has tested positive. And we also then don't know what the 60-day aging rule does to the survival of the virus. So that's still out there. We have seen some things around raw milk consumption. So Elisha alluded to both of these in her presentation. We do know, right, from the CDC epidemiological study at one of the Texas farms where they found that the cats, 50% of the cats had died. They attributed that to the cats being fed raw milk and raw colostrum. Again, so suggesting that ingestion might be a route of transmission for this virus. And then that same New England Journal of Medicine study that I was referencing there for the heat inactivation study, they also did a study where they were feeding the mice. They fed the mice 50 microliters of a solution containing 3 × 10⁶ PFU of the virus. And they noted that the mice started showing illness starting on day 1. And Elisha showed you what organs they found the virus in. So again, suggesting that there is a potential route of transmission. They still think it's probably right in the thorax and the throat, getting into the lungs, not through like the intestines or anything like that. but that there is a potential route of transmission with the consumption of raw milk, at least in these two other mammals. So all reasons why, on top of the other risks that we have for raw milk, why we should be avoiding raw milk consumption at this time, and definitely not thinking that we get any benefits of drinking raw milk that has H5N1, because we've seen some interesting media reports around that, and I'd say that that's a pretty bad idea. I'd say that also highlights, right, that we don't want to be feeding back raw milk that is positive for H5N1 back to our animals on farm. If you're going to be doing that, you're going to want to make sure that you have an inactivation step, geliothermal inactivation step to deal with that. What is the right time and temperature treatments for that? Again, we still need to get those specifics outlined. But at least pasteurization. And then also think about how you're dumping any contaminated milk on farm to make sure that it is not a vector of contamination to wild animals in the environment. So, and that kind of rounds us out on what we've seen so far on the food side, from the inactivation work and on the raw milk. Recommendations are still there for PPE if you're handling raw milk. And I just threw this up here just so people could see it and remember that there are recommendations on the CDC website. And I'd check those out if you're working with raw milk on farm. And with that, I will open it up to the group.